Since the dawn of logic, humanity has sought to master the language of numbers. From rough fingers arranging pebbles on the sand to the rhythmic clicking of the ancient wooden abacus, we climbed the stairs of calculation. Even the rusted gears of the Antikythera mechanism remind us that our quest for precision is thousands of years old. Since the dawn of logic, humanity has sought to master the language of numbers. From rough fingers arranging pebbles on the sand to the rhythmic clicking of the ancient wooden abacus, we climbed the stairs of calculation. Even the rusted gears of the Antikythera mechanism remind us that our quest for precision is thousands of years old. Ink fell on yellowed pages as scholars labored over rows of digits. But soon, the flicker of vacuum tubes in the dark signaled a new era. The world watched as bulky tubes shrank into microscopic transistors, turning the impossible weight of math into a silent flow of electrons that would change the world forever. We moved from tangled wires and massive machines weighing dozens of kilograms to the birth of the liquid crystal display. For the first time, numbers appeared in clear, black lines on a grey screen. We learned to capture the energy of the sun through a lens, turning pure light into the power of logic. An ancient key opens the door to a digital future where binary codes dance in virtual space. Beneath the thin lines of a modern blueprint lies the ultimate contrast. The wooden beads of the past standing beside a silicon microchip no larger than a fingernail. History and technology are finally meeting at the summit of precision. The sepia tones of the past dissolve into the brilliant silver of the modern age. Under the glow of LEDs, the smart factory is awakening, and the symphony of automated production is ready to begin. The creation begins with pristine ABS resin flowing into the line. We mix in the deep greys and blacks of modern design before hydraulic presses stamp the shells into shape. As robots lift the warm plastic from the molds, steam rises, a signal of a new form being born from the marriage of heat and pressure. Soft silicone is molded to create the elastic heart of the keypad. Through double injection laser printing, we ensure that every digit remains permanent, never to fade. Robotic arms polish the edges of the frame to a flawless finish, while we test the durability of the keys through 50,000 relentless cycles. Paper-thin circuit boards are fed into the machines. SMT technology scans silicon solder onto every contact point before pick-and-place robots position microscopic chips with surgical accuracy. As the boards pass through the intense heat of the reflow oven, the digital brain is permanently fused into place. Connections as thin as human hair link the screen to the brain. We apply a protective black seal over the central processor, while automated sensors verify the conductivity of every path. Two ultra-thin glass plates are then joined with liquid crystals, forming the window through which the world will see its answers. Lasers divide the glass into 12-digit displays, and polarizers are applied to the surface. We forge solar cells from deep blue silicon crystals, welding thin silver electrodes to capture every ray of light. Under intense lamps, we measure the voltage, ensuring that the sun will power every calculation. The assembly converges. The silicone keypad is nested into the front frame, followed by the PCBA board and the LCD display. This is a layered dance of logic and electronics, where every component is positioned with absolute certainty to create a bridge between a human touch and a digital answer. The solar cell is fitted above the screen, and a backup battery is installed for the shadows. The rear shell is locked into place by automated screwdrivers, and anti-slip rubber pads are applied to the base. For the first time, the screen awakens, displaying a perfect row of 8s across its clear face. Robots execute complex functions to verify the logic. We test the LCD contrast from every angle and drop the units from heights to prove their resilience. In high-temperature chambers, we push the microchips to their limit, ensuring that our precision remains stable even in the most demanding environments. We verify performance under low-light conditions and scan every surface for the tiniest flaws under UV light. After an ionized air bath clears away the dust, the machine is pristine. Every technical mark is etched by laser into the shell, signifying a product that meets the world's highest engineering standards. Sustainability is built into our soul. We crush scrap resin for a new life and purify our wastewater until it is crystal clear. Our factory breathes with nature, utilizing solar energy and circular systems to power the innovation that builds the tools for your daily logic. Final inspections are performed by hand in sterile environments. Products are nestled into recycled pulp trays and sustainable cartons, reflecting our respect for the planet. We include a simple manual printed with soy-based inks, providing the final guide to a device that will last for decades. Automated systems move the finished boxes into a smart warehouse where robots manage the inventory with mathematical perfection. From the shimmering maze of the microchip to the light hitting the solar cell, every detail is a testament to the quiet power of precision and order. Robotic arms move with effortless grace as engineers monitor the pulse of the factory. A single drop of oil keeps the gears turning, while rows of calculators stand like a silver army on the assembly line. We are turning raw plastic and silicon into instruments of pure, undeniable truth. Lasers etch the lowest power consumption ratings into the steel, showcasing a harmony of efficiency and performance. Our factory harvests rainwater and recycles energy, creating a sustainable environment where technology and nature can thrive together in a silent, productive partnership. From high humidity tests to the final polish of the LCD, we never stop striving for perfection. We strip down sample units to educate and inspire, proving that behind the simple shell lies a world of sophisticated science. As the lights dim, we celebrate another cycle of successful creation. On a student's desk or an architect's table, the journey of numbers continues. Technology doesn't replace the human mind, it empowers our hands to build bigger and reach further. Every digit that flickers on the screen is a brick in the wall of a new world being built today. From the classroom window to the recycled materials of a circular life, we are fostering a legacy of wisdom. A simple smile from a scientist confirms a complex truth, proved by a device that asks for nothing but a little light. We are shrinking the hardware while expanding the human potential. We see a future of biodegradable materials and global connection, where math bridges the gap between continents. Every reflection of the sun is a reflection of hope. We are refining our world, making it smarter, cleaner, and more precise for the generations to come. In the quiet sanctuary of a library or a design lab, we find the peace of certainty. The ancient abacus and the modern microchip are finally one. As the factory fades into the blue sky, we leave you with one final truth: accurate numbers, a sustainable future.